All right, Mr. Ahmed here for 7.5 part 2. Today we're going to work with kites. And a kite is a quadrilateral, so a four-sided figure with two pairs of consecutive congruent sides. So what we mean by consecutive is it means that they're connected to one another. In the parallelograms, the congruent sides were opposite of one another. Consecutive sides are connected at a common vertice. So EK and ET, those are consecutive sides and they are congruent. KI and TI are consecutive sides and they are congruent. And we also just drew one diagonal in EI, not really necessary. So we're looking at the whole figure, KITE, that is the kite. So, some special characteristics of a kite. A kite has perpendicular diagonals. So if a quadrilateral is a kite, then its diagonals are perpendicular. So when I draw on the two diagonals, we get four right angles in the middle. So CA is perpendicular to BD. Kind of obvious too when you kind of look at it. You'll notice if it's drawn anything to scale, that's going to be perpendicular. So, next step. If a quadrilateral is a kite, then exactly one pair of the opposite angles is congruent. The other pair is not. Most specifically, the congruent angles fall between the non-congruent sides. So angle A is congruent to angle C, and angle B is not congruent to D. Those are different sizes. So, a couple example problems here. I have my kite, QRST. I'm supposed to find angle T. So angle T, I'm going to call that X. Now, these two are the non-congruent angles, so that means T and R have to be the same size. Now, it's a four-sided figure, so all four angles add up to 360 degrees. So, four-sided figure, 360, we'll say 70 plus X plus 88 equals 360. Then we can solve 2X. 70 plus 88 is 158. Subtract our 158. And we get 202. And divide by 2, and we get 101. So if X is 101, that means that the measure of angle T is also equal to 101 degrees, and R would also be 101 degrees. Next example here, looking for angle K. So we have to see which pair of angles is congruent for this kite. Well, in between the two non-congruent sides, E and I have to be the same size, so they're both 90. For me to find K, I have to subtract from 360. Again, it's a four-sided figure, so all four angles have to add up to 360. So I'm just going to use a calculator for this one. I'm going to say 360 minus 90 minus 90 minus 107, and I get 73. So the measure of angle K is 73 degrees. All right. Next one. West is a kite. So I'm told that UW is 3. US is 3. Keep in mind this is a right angle. EU is 5. And I'm supposed to find the following. So I'm supposed to first find EW, WE. So a couple things about that here. I think you've seen Pythagorean's theorem before, so I'm going to use Pythagorean's theorem on this example. We skipped a couple of the other examples in previous notes based off of it being a right triangle, but this is a right angle, so I'm going to use Pythagorean's theorem. This is the hypotenuse. We'll call that x. So 5 squared plus 3 squared has to equal x squared. And then we'll solve. So 5 squared plus 3 squared is 34. So x squared is equal to 34. And then from there, we could take the square root of both sides, and we'll just leave it as x is equal to the square root of 34. And ES is the same size because it's also 5 and 3. So ES is the square root of 34. And then we were supposed to find WT. So UT is 12. So again, I could use Pythagorean's theorem to find this piece. We'll call that Y. So 12 squared plus 3 squared is equal to Y squared. And then I'd be able to solve that. So 12 squared plus 3 squared is 153. Then we'd take the square root of both sides, and y would equal the square root of 153. And then if we want to simplify this radical, I believe we did that a little bit right at the beginning of the year. For me to simplify the square root of 153, I'm looking for the perfect square factor that goes in. That is 9. So we could take this and break it apart to 9 times 17. So we have square root 9 times square root 17. And we get 3 times the square root of 17 for WT. And ST is also the same size. So that's 3 times the square root of 17. So just a little Pythagorean theorem problem there. I probably won't see one of those on the test, but thought it was worth doing here. You'll see a lot of right triangles as we kind of keep going. So the two congruent angles of your kite you have at home are 124. So I'm going to draw a little kite here to the best of my capabilities. We'll call it like that. I don't know. 124, 124. Those are my two congruent pieces for my kite. It says of the two remaining angles, one is 7 times larger than the other. So my remaining ones, this one will be x, the other one's 7 times that, 7x. Now we can set up an equation to solve. 7x plus 124 plus 124 plus x has to equal all four angles, 360. 8x plus 248 equals 360. Subtract our 248 and we get 112. And when we divide by 8, x is 14. So it said to find the measure of the smallest angle. The smallest one was x, so that's 14 degrees. We got it. And just a couple things here before we wrap it up. All of this extra practice material, some of this we're going to do in class. This first box here is super helpful for you to kind of organize the different processes and different properties of each shape. So I'm going to kind of go through a couple of them. So like with a parallelogram, I know that the diagonals bisect each other. I also know that's true for a rhombus. I also know that's true for a rectangle. I also know that's true for a square, not for a trapezoid, not for an isosceles trapezoid, and not for a kite. Now, a couple things. If it's true for a parallelogram, it's going to be true for the rhombus, the rectangle, and the square no matter what. So the diagonals are congruent. That's not true for every parallelogram. It's not true for every rhombus, but it is true for a rectangle. If it's true for a rectangle, it has to be true for a square. Okay, the diagonals are congruent in a square. And you could just use this chart to organize some materials. Like I said, I'm not going to go through the whole thing right now. We'll probably do that some in class. And some of these always, sometimes never questions, we'll also probably view those in class as we're going along. A couple of these as well, just identifying the figure. Is it a rhombus, rectangle, or square? Now, these are totally not drawn to scale. So when I look at this diagram, it does not look like a square at all. These sides don't look like they're the same length. However, we have to go by the tick marks. All four sides are the same length. If all four sides are congruent for a quadrilateral, guess what? It has to be a rhombus. Okay, it has to be a rhombus. This one, these sides don't look like they're parallel, but they're marked. It has one pair of parallel sides, therefore it is a trapezoid. So just super tricky. Take a look at some of those. Again, we'll do those in class. And again, this is just another diagram that you could use to keep your information organized. We might go through this during class at some point, or you can fill it out on your own. Choice is yours. And lastly, this here diagram is super helpful. All right, this flow chart kind of tells us we have quadrilaterals. It's a four-sided figure, and the only thing we know is that the angles add up to 360. At the bottom is a square, so that's the most specific quadrilateral. And if you work your way up, if the shape's a square, you know it's a rectangle, and you know it's a parallelogram, and you know it's a quadrilateral. However, I can't necessarily assume that as I work my way down. If it's a quadrilateral, it's not necessarily a square. It could be sometimes, but not always. A square is always a rectangle. It's always a parallelogram, and it's always a quadrilateral. And kind of the same things here with these trapezoids and the kites. Just has everything labeled in with all this specific information for you. All right, that's it. Have a good day.